The current module deals with pre-installation considerations and documents for a Ceragon installation and commissioning project. The agenda of this module covers the following topics. What are the roles and responsibilities of the installation team? What is the installation process from start to end? What is a technical site survey document for your site? What is a site RFI ready for installation? What is the equipment bill of material? What is the radio frequency planning document, otherwise called the links budget? An example of the acceptance and commissioning procedure used by Ceragon. Whenever planning or working towards implementing a project of installation, there are a number of roles and responsibilities that come into play. From the team leader and technician's perspective, it is important to adhere to these. First of all, respect the rules for safety, and no team member is allowed to perform any task due to fatigue, sickness, or mental stress, or is under the influence of drugs, alcoholic drinks, or prescription medication. Remember, it is everyone's job and should be treated with utmost respect. Secondly, pay attention as well to what your colleagues are doing. In the event that they are doing something in a wrong manner, please warn them and show the correct way, or at the very least say something to your supervisor. Thirdly, make absolutely sure that anything that seems suspicious gets reported to said supervisor. This can include observations about the wrong equipment, wrong quantities, wrong labels, wrong working procedures, not respecting safety instructions, operating machines without a permit, hoisting or lifting inappropriate weights, using the wrong tools, or using tools that have not passed inspection. Lastly, always read and make sure you understand the instructions available first. This should be done prior to any work with a new equipment. Let's have a look at the flow of the installation process and steps from start to end. First of all, after getting a quotation based on the technical requirements, there will be a contract and a purchase order from the client towards Ceragon. After the PO, a team from Ceragon will create something called a technical engineering configuration, detailing all of the information regarding each site installation and configuration, what equipment is used, in what way, how many ports and what ports are used, where are the cables ran through, how do the indoor and outdoor installations look like, how many connections, what position on customer devices, etc. Once the previous step was finished, the implementer of the project will conduct a technical site survey, as discussed in this module. After the site survey and after the production of the equipment is finished, a confirmation for shipment is sent to the local office warehouse. Then, the site RFI ready for installation visit happens to confirm that everything is ready for the installation project. The shipment of the equipment from warehouse to site location happens next. A confirmation and inspection of the equipment received per site needs to happen. This is already happening with the involvement of the installation team of technicians. The actual installation happens on site. The acceptance test procedure takes place at site, confirming the equipment functionality, performance, and interoperability with client equipment. A partial or final acceptance agreement is signed by the client and the handover is taking place. From now on, the site is the responsibility of the customer. Considering our efforts to look at all of the documentation needed before the actual installation, let us begin with the technical site survey. The technical site survey is a document that captures all the relevant site information prior to a project installation or an upgrade project. The document is a checklist for verifying all of the necessary conditions for the new installation or upgrade. During the site survey, the observer checks for site readiness, site access, presence of power on site, capability of supporting the installation or the upgrade, line of sight, what equipment is already present on site, and other details. This is a list of items that are observed in a Ceragon technical site survey. General data, date, customer name, name of representative, site name, GPS coordinates, site type, room type, key availability, mobile contact of the site representative, etc. Remarks and observations about site, parking, distances, storage availability, light, AC power, AC outlets, etc. Safety issues, safety conditions, cellular site coverage, climbing mechanism. Terrain and line of sight verifications, GPS coordinates and altitude, line of sight, propagation conditions, possibilities for interferences, etc. Tower orientation and layout, size, height, azimuth, microwave equipment on site, manufacturer, voltage, power supplies, number of antennas, pole mounts, etc. Required antenna, ODU cabling and materials data, list of materials requirement, DC power cables, Ethernet or optical cables, grounding kits, required bolts and their type. Transmission data covers the existence of the following: electrical or optical Ethernet ports type, speed, type connections, entry gland, extra room for cables, quantity, entry. Site survey checklist. For an example showing a technical site survey document, please look at the object to the right side of the screen. Site ready for installation document. The site ready for installation document demonstrates the site's readiness to accept a new installation project. Before visiting the site, this checklist can be used to check all of the relevant items needed for a proper installation or upgrade. This checklist will cover 6 major issues which repeat in each region for the revisits. Access and permission to the site. Material, equipment present on site. Weather. Power at site. Subcontractors involved in the project. Line of sight check. This checklist needs to be checked and implemented before visiting the site in order to reduce costs, manage resources, and avoid revisits in the sites. The high-level design includes the following 2 separate scenarios. Worldwide coverage, excluding countries in Asia-Pacific. Asia-Pacific countries. For 1, the worldwide minus Asia-Pacific checklist includes access and permissions to the site, having the right key for the site and the correct papers and permissions. Yes or no? Material, have all of the correct materials made it to the site? Yes or no? Weather forecast is proper for the installation? Yes or no? Power is available at location from the site owner? Yes or no? Does the subcontractor have all the needed resources available for the site installation? Yes or no? Is the documentation of the line of sight available and valid? Yes or no? Is the data connectivity planning with IP made ready? Yes or no? Decision-wise, is there a go-ahead for the installation? Yes or no? For 2, the checklist for the Asia-Pacific countries. Is there a valid permit for accessing the site? Yes or no? Is there a key available for opening gate, fence, rack, enclosures, cabinets, etc.? Yes or no? Is there an antenna height approval from tower or site owner? Yes or no? Is there an approval given for the link budget? Yes or no? Has the network been prepared for the installation, disconnect, shutdown node, traffic, etc.? Yes or no? Is all of the equipment available on site? Yes or no? Has the power outlet been checked and is valid? Yes or no? Is there proper DC power supply available and ready? Yes or no? Do you have the IP address and the correct VLAN for remote connectivity to your network element? Yes or no? Have all the labels for equipment identification been placed correctly? Yes or no? A timestamp and the name of the person who completes the checklist is required. Use in progress status for the service task. The following is a list of permissions and implementations to be verified from region to region when use the Ceragon Inside tool. In Europe, the project manager is responsible for checking the permissions 1 week before the site visit. In South Cone countries, the service coordinators are responsible for checking the permissions 1 week before the site visit. They also need to change the status of the service task from planned to in progress in Inside. In Andean countries, it is the responsibility of the project manager for checking the permissions 1 week before the site visit. They also need to change the status of the service task from planned to in progress in Inside. For Asia-Pacific countries, the quality assurance lead will do the same task 1 week before the site visit. In African countries, the project manager is responsible 1 week before site visit. In India, the responsibility falls with the project management office department to do the task at least 2 working days before the site visit. For North America and Brazil, this is not relevant. Details about the equipment boom or bill of material, also called bill of quantities, sometimes. The bill of material or bill of quantities is a document that states the list of all equipment needed on an installation and their respective quantities. The correct document should show the items and quantities per site. Some of the most important parts of the document are equipment listing, what type, how many and what subcomponents are to be used per each site, each end on the link. Activation keys, what licenses are to be installed on each unit. RFU, what radio outdoor units are to be used on each site on the link. A specification about high or low frequency radio units will be present in the document. Accessories on site, cables, connectors, waveguide, mediation devices, SFPs and adapters. Antennas, model name and number, with specification of height, frequency and polarization. Other equipment can be present as, for example, the NMS server hardware specifications for the Network Operations Center. In this example, you can see that the list contains the product type and name, the specific Ceragon part number, a description of the mentioned equipment and the correct quantity to be installed on site. The Radio Frequency Planning Document. The radio frequency planning is a complex document that shows planning for the radio link availability and specifications for the link. To make it easier to understand, we will use an existing example to point out the most relevant aspects of the document. The document includes information about radio planning, what frequencies and channels are used and in what spectrum band. Antenna heights against the terrain profile as showcased through the planning tools. Link distance in kilometers. Polarization used on the link. Radio model used. Antenna model used. Fade margin calculated based on the weather statistics of the region. Annual radio availability percentage. In this example of a link report, you can see the contained columns along with the details for one specific link, which is our example, the radio link between Brown County and Copper Tower. We will consider only this link, the first row of the table, marked in blue. The exemplified link is a 18.14 kilometers link, planned for 6.2 GHz frequency, in horizontal polarization, with the Fiber IP20C high power. The antenna height in Brown County will be 42.7 meters while in Copper Tower it would be placed at 54.9 meters. We see that the effective margin for each side of the link is planned at 23.29 dB. Last column shows the planned annual radio availability considering the effects of rain fading and multipath for that specific region and distance. This is calculated in correlation with the frequency, the signal-to-noise ratio for a specific channel bandwidth and modulation profile. The tool used by the radio planning team helps to represent the links. Please observe the link from previous slides superimposed on a geographical map for better understanding of the link conditions. The path profile report shown here explains the radio planning for the exemplified link between Copper Tower and Brown County. You will see that this report also shows the antenna height in relation with the sea level and the ground level for each side of the link. Furthermore, the report shows the azimuth value in degrees for the antenna course installation. This is a detail of most importance for installation teams due to the fact that based on this, will be decided what face on a tower and the antenna offset to be used. Path length, frequency, K-factor values are also present in this profile report. The transmission details report is a more detailed view of this specific transmission between the two ends of our link. The report shows latitude and longitude details, azimuth, vertical angle for each antenna, elevation per each antenna model, antenna gain, polarization of the signal, all of the losses from the intermediary connectors and accessories and climatic conditions like temperature, rain specifications, fade occurrence. The link budget report shows capacities, transmission power, planned received level signal, threshold levels and fade margin for each modulation profile available for the installation. In our example, the bolded 256Q AM offers above 450 megabits per second, because this is the needed minimum capacity required by the client, and a planned received signal of -36.4 dB. The availability report shows the radio link availability for each modulation profile. In this example, the client asked for a minimum 99.995 radio link availability, which can be obtained from the link with at most 256Q AM modulation and not higher than that, for these specific conditions. The rest of the modulation profiles can be used as well, and they will increase capacity, but lower the availability of the radio link. Please observe this in the table presented. Now, about the acceptance and commissioning procedure. With Ceragon, the aim of the acceptance and commissioning procedure is to verify the correct installation and operation of the installed link. As part of the same process, the interoperability with the customer equipment will also be verified. This procedure helps to verify that all of the installation requirements were noted, implemented, and checked after implementation. The document of acceptance and commissioning is also a summarization of the installation requirements. The procedure is comprised of the site acceptance procedure and the commissioning of the radio link. Let's discuss the site acceptance procedure. The site acceptance procedure ensures that the site has been properly installed and is ready to be handed over to the client with correct installation. The information in the adjacent document oversees the following items. Site information like the name, the model of site, the customer, the address of the site, and the radio code. Antenna mounting. Antenna. Outdoor unit, also called RFU or ODU. The validation of the Ethernet cable or optical fiber being correctly installed. Flexible waveguide in case of remote mount proper secured. Interconnection to customer's indoor unit. The availability of correct and stable DC power supply and adjacent batteries. A general information section to help other visitors to the site for troubleshooting or maintenance. In the antenna mounting inspection, the following things need to be understood. If the mounting pole is high enough to clear obstructions, parapets, cleaning gantries, and lift housings. If the mounting pole is high enough and well positioned so that no person could walk in front of, or look directly into the path of the microwave radio beam. The pole should be away from the edge of the building or tower, where possible. That the mounting pole is secure and perpendicular, helping with antenna alignment. That the mounting pole is grounded as per site or per operator specifications. Metal structures must be connected to the existing lightning protection of the building or tower. Beyond the 45-degree cone of protection from existing conductors, additional lightning protectors should be installed. All steelwork is galvanized or stainless steel, as appropriate to prevent corrosion. Any mounting screws or bolts have anti-corrosion measures as well. In terms of checking the antenna installation, please look at the following items. That the antenna is grounded as per site specifications. That the antenna sway braces are fitted and installed correctly. That for the 1.2 meters or larger diameter antennas, an extra side strut is fitted to either the mounting frame, or to an alternative point like directly to the tower. That the antenna water drain plugs are fitted to allow any moisture that forms on the inside of the antenna or the radome to drip out and prevent accumulation within the antenna. That the drain plugs fitted at the bottom of the antenna should be removed after installation. Verification of the outdoor unit or the radio frequency unit involves the following. Checking that the ODU is grounded as per the installation instructions discussed at length, a little later in this course. Checking that the ODU polarization is aligned as per link requirements and matches the polarization of the antenna. Whenever in an all-outdoor installation, also see that the proper mediation devices are used. Checking that the interconnection from ODU to customer equipment, via the optical fiber or Ethernet cables is done properly. Checking that the installed cable glands to the ODU is done as per instructions, to protect against humidity. Verification of the indoor connections means checking the following. Checking that the traffic connections are correctly terminated, crimped, and secured. Checking that the fiber optic patch leads are routed carefully and efficiently, with no extra loops, no unnecessary coils. Checking that the other user terminations are securely and correctly terminated. Checking the complete labeling per site requirements. Remember that labeling is specific to each customer, but typical labeling requirements may include the antenna labels, used for link identity and bearing. The ODU labels used for link identity, frequency, and polarization of the link. Ethernet or optical fiber cable labels, for link identity, close to the ODU, customer equipment, and either end of any joint. Power cable labels, for getting the link identity. The radio link commissioning procedure. The purpose of the commissioning tests is to verify correct and proper operation of the product, within plan specifications. This test is comprised of a link verification, seeing the remote radio across the link, observing planned received signal level, mean squared error and other indicators as per the link budget. An Ethernet line interfaces test, to observe correct functionality of the Ethernet interfaces. Interoperability verification. Management verification, the availability of this endpoint from the server or from Network Operations Center. During the link verification stage, some other elements need to be observed. The radio LED on the ODU is green, indicating the radio link is up, without errors on it. The received signal level, or RSL, is observed at up to plus or minus 3 dB from the expected level at both ends of the link, as per the link budget. The radio's bit error rate, or BER, is 10 to the power of minus 11 or higher. If working with ATPC is operating as expected, RSL equals reference level. After connecting test equipment or end equipment to the enabled Ethernet interfaces, all LEDs on the customer equipment shows activity. The Ethernet line interface test, explained. Once devices are powered up, connect Ethernet packet analyzer to the gigabit Ethernet port. At the other end of the link, use either a physical loop for fast Ethernet or connect a second analyzer. A logical loopback on the Ethernet interfaces can also be used. Run a test for packet loss for at least 1 hour. Use a load rate as per Ceragon specifications for the chosen MRMC script or per the planned capacity. Save the results of the successful test in a report on your computer or in the traffic analyzer. The interoperability verification means that the customer equipment can correctly communicate to the Ceragon network element. Please connect customer's end equipment to the line interfaces and verify correct operation. Must be done after verification of the link and Ethernet service verification. Further interoperability tests can be performed in accordance with the specific requirements of the connected end equipment. Management verification means 2 types of access to the network element: local access to manage it and remote access from a server or network operation center. You verify management or supervision by launching the browser to verify HTTP management and verify that you can manage the link and that you are able to perform changes to the link configuration, frequency channel, TX power, system name, time and date, etc. This can be done either via the management port or the specified port for management from the plan. Verify that correct parameters are reported when performing the above. Verify that there are no active alarms on the link. Verify that the management station can manage the link and receive information from the link, minor alarms and traps. This should be obtained once the element is connected via Ethernet through the correct IPv4 or IPv6 address. This module has covered the following topics. What are the roles and responsibilities of the installation technician? What is the installation process from start to end? What is a technical site survey document for your site? What is a site RFI ready for installation? What is the equipment bill of material? What is the radio frequency planning document, otherwise called the link budget? An example of the acceptance and commissioning procedure used by Ceragon. Thank you for your attention.